Okay, we have another couple here that we'll do. Again, we're adding and subtracting rational expressions. Rational expressions, when you add them or subtract them, just like fractions, you have to have a common denominator. So in 5a, we have a minus 1 and a 1 minus x. We want to factor first if we can, because that then helps us see what factors the bottoms have in common and what they're missing. Now this is a special case. If you look closely, we have ax minus 1 and then 1 minus x. These are considered opposite expressions. Kind of like if I had a 6, the opposite expression would be negative 6. They're just negative versions of each other. So in this case, these are just negative versions of each other. So whenever we have a negative version, to flip it around, we just multiply it by negative 1. Now I'm going to put this in brackets to remind myself it's a factor, and this is a factor. So we have negative 1. We're going to multiply the top and the bottom by negative 1, negative 1. So as I multiply this through, it becomes x minus 1, because whenever you multiply something by 1, it becomes the opposite version. So negative 1 multiplied by 1 becomes negative 1. Negative 1 times by negative x becomes a positive x. All right. On top, 1 multiplied by negative 1 becomes a negative 1. I wrote that too close to the top, so I apologize. And then I have x minus 1. The bottoms, or the denominators, are the same in this case, so now we can write it as one happy fraction. So on top we have 2 minus negative 1. On the bottom we have x minus 1. Now, 2 minus negative 1, it might blow your mind here, but it actually becomes positive 3. Remember, when we're subtracting negatives or subtracting polynomials, we leave, change, change. So this becomes a plus, this becomes a plus, this stays the same as a positive 2. So 2 plus 1 is 3. If you don't believe me, you can use your calculator to check it. All right, so then we have x minus 1. The non-permissible values, we look up here, what's going to make the bottoms equal 0? It's going to be x cannot equal positive or negative 1. This is our final answer. All done. Now to B. B again is another example of having opposites in the bottom. Notice here, this is in factored form, which is nice of them to give us a factored version. So both bottoms have a factor of m. That's good. This one has a m minus 7. This is a 7 minus m. Notice these two in the brackets are opposites of each other. We want to make them the same. So we'll multiply the top and the bottom by negative 1. Negative 1 times 7 becomes a positive, or negative 7. Negative 1 times positive m. Oh, I messed that up. Negative 1 times negative m becomes a positive m. So the bottom becomes m minus 7. Because we multiply this negative through, it goes away because we use it as we multiply through. Ooh, that was a crazy line. So we have an m minus 7, same as here. They're the same denominator, so we can write it as one big happy fraction. We have 5m plus 1, and then we add this expression here. Now when we multiply this fraction by negative 1, we have to multiply by everything in here. So we go negative 1 times 4m, negative 1 times 8. It becomes a negative 4m and a negative 8. Okay. So we combine the like terms now. We have 5m and negative 4m. That becomes 1m, or just m. We then have a plus 1 and a negative 8. That is minus 7. All over m minus 7. Now, notice that we have a common factor. We have m minus 7. It is the only thing on top, and so we can consider a factor because it's all of it is a factor. You can always put brackets around everything in a fraction. We have an m minus 7 on the bottom. Those cancel out. Now, a mistake that lots of students make is they say, okay, well, the only thing left is an m, so the answer is m. That's incorrect because the m is on the bottom. On the top, you say, well, there's nothing left, so maybe a 0 goes there. That's not the case. We have to remember that there's always an invisible 1 in front of a set of brackets. So even though everything is canceled out, remember the invisible 1. The invisible 1 becomes just 1 on top because that's the only thing left. So our final answer is 1 over m. Our non-permissible value, again, we go back to the top. M cannot equal 0, positive 7, and negative 7. Actually, no, just positive 0 and 7. Okay, thank you very much.